Okay, Algebra 2. Chapter 3, Section 1 deals with quadratic equations. This section also brings in a couple things that we haven't discussed yet, so we're just going to touch lightly on them, and we will see them later in the school year. Quadratic equations have two solutions. They can be real or imaginary. So also in math, there are imaginary numbers, and we'll talk about that in a little bit. It's denoted by x squared. So anytime you see x squared in an equation, you know you're going to be dealing with a quadratic. The parent function, f of x equals x squared. So just like the absolute value, we had f of x equals the absolute value of x. With quadratic functions, we have f of x equals x squared. Again, that x squared telling us we have a quadratic. Our parent graph. If we were to go ahead and graph this, if I plug in 0 for x, 0 squared is 0. So my first point would be 0, 0. If I plug in 1 for x squared, 1 squared is 1. So I have the point 1, 1. Plug in 2. 2 squared is 4. So we go 2 and 4. Plug in negative 1. Negative 1 squared is 1. So we have the point negative 1, 1. And then negative 2 squared is 4. So we have negative 2 and 4. So your quadratic is in the shape of a U. Quadratics give us a parabola. That is the mathematical name for it. So it's kind of like a U. It could be opened upwards, downwards, to the side, to either left or right. The domain, just like the absolute value, we're going to go from negative infinity to infinity. And then my range for your parent function, if you look, there's nothing on the y until you hit 0. So y is going to be greater than or equal to 0 in this case. We're going to do a little bit with square roots as well when we go to solve these equations. Since you do have x squared, in order to get x by itself, you're going to have to take the square root. And we talk about square roots more later on in the school year. So this is just a little touch base on square roots, two things that you're going to need. There's two rules. The square root of AB, A times B, is technically broken down into the square root of A times the square root of B. So if we have the square root of 12, what times what is 12? 4 times 3 is 12. You always want to pick something that has a perfect square. So the square root of 4 is 2. Square root of 3 is not a perfect square, so it's just going to stay the square root of 3. So the square root of 12 technically equals 2 square roots of 3. The second rule is if you are dividing in underneath your square root, so the square root of A divided by B equals the square root of A divided by the square root of B. So an example of that, the square root of 5 over 9, it's the same as saying the square root of 5 divided by the square root of 9. Square root of 5 is not a perfect square, so it's just going to stay the square root of 5. Square root of 9, however, is 3. So your final answer there is the square root of 5 over 3. Just something to note. A square root cannot be left in the denominator. So if this wasn't a perfect square, we would have had to rationalize the denominator, which we will talk about at a later time. So example 1, we want to solve the quadratic equation by taking square roots. So pretty much we want to solve for x. So we're going to do what we normally do when we solve an equation. We're going to add 16 to both sides. That's going to cancel. We have 2x squared equals 16. I'm going to divide both sides by 2. X squared is going to equal 8. And then I'm going to take the square root. In order to get rid, the square root cancels out the square. So I'll just have x. And that's going to equal plus or minus the square root of 8. Anytime you take the square root, you have the option of it being positive or negative. And the square root of 8 can be broken down, just like we showed in those rules. What times what is 8? The square root of 4 times the square root of 2. And then the square root of 4 is 2. So 2 square roots of 2. If you use your calculator, if it's one of the ones like the yellow ones, the TI-30X, whatever, that will break that down for you. So x is actually going to equal plus or minus 2 square roots of 2. Same thing with part B. I'm going to solve it just like a regular equation. I'm going to subtract 9 from both sides. I'm going to have negative 5x squared equals negative 9. I'm going to divide both sides by negative 5. So x squared is going to equal 9 over 5. I'm going to take the square root of that. X is going to equal plus or minus the square root of 9 over 5. Now that can be broken down to the square root of 9 over the square root of 5. Square root of 9 is 3. And we have a square root left in the bottom because the square root of 5 is not a perfect square. So we have 3 over the square root of 5. Anytime you have a square root in the bottom, you just want to multiply the top and the bottom by that. So you have plus or minus 3 square roots of 5 over 5. And that is your final answer for x. Multiplying a square root by itself cancels out those square roots because that's technically the square root of 25. Square root of 25 is 5. When dealing with real-world problems that deal with quadratics, there are 2 formulas that are usually used. So anytime you're given a real-world problem, it's going to be one of these 2 formulas. So if you have the distance fallen in feet at a time in seconds, so d of t, your distance at a time, equals 16t squared. That's one formula. And then if you have a height in feet at a time in seconds, h of t is going to equal h subscript 0 minus 16t squared. And that h subscript 0 is the object's initial height. So anytime you're given a starting height, that is your h of 0, or h0. So example 2. If you drop a water balloon, how long does it take to fall 4 feet? So we're not talking about any height, we're just talking about a distance. So we're going to use the d of t equaling 16t squared. So d of t equals 16t squared. We are talking about a water balloon that falls 4 feet. We want to know how long it takes. So 4 feet is going to be my distance. So we're going to plug that in at this side of the equation. So 4 is going to equal 16t squared. And then I'm going to just divide both sides by 16. We'll have 4 over 16, which becomes 1 over 4, which is going to equal t squared. Take the square root of both sides. So we have the square root of 1 over the square root of 4 equaling t. Square root of 1, plus or minus. So we'll come back up here. Plus or minus the square root of 1 over the square root of 4. Square root of 1 is 1. Square root of 4 is 2. So we have plus or minus 1/2. Since distance cannot be negative, we have to use the positive. So t is going to equal 1/2, meaning that the water balloon falls 4 feet in 1/2 a second. Part B. The rooftop of a 5-story building is 50 foot above the ground. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? So in this, we're talking about a height. We have an initial height of 50 feet. And we also have another height given to us. We want to know how long it goes from 50 feet to 24 feet. So we're going to use h of t equals h0 minus 16t squared. H of t is going to be the height that I want to know what my time is. So that's going to be that 24 feet. My initial height is 50, and then we're going to subtract that 16t squared. So I'm going to subtract 50 from both sides. And we're going to get negative 26 equals negative 16t squared. And I'm going to divide both sides by negative 16. Doing that, that's going to give me 26 over 16 equaling t squared. Take the square root. Again, we'll come back up here. So I have plus or minus the square root of 26 over 16 equaling t. So I technically have the square root of 26 over the square root of 16. Square root of 26 cannot be broken down. So t is going to equal positive square root of 26 over 4. That is about 1.3 seconds. And that's your answer. So just like absolute value, quadratic equations, if it's positive, has 2 solutions. If x squared equals 0, there's 1 solution. And if x squared equals negative 1, it technically is no solution, but it has no real solutions. In math, they came up with something called an imaginary number. And it deals when you have the square root of a negative number. So an imaginary number is a square root of a negative number. It's written as bi. B is the real number, I is the imaginary unit. Negative I equals the square root of negative, or this is just a little note. We'll do this. Not negative I equals the square root of negative 1. I squared equals just negative 1. So I want you guys to recall the product property of exponents. AB raised to the m power is a to the m times b to the m. Hopefully you saw that in Algebra 1. So in example 3, we're going to deal with these imaginary numbers, and we just want to find the square. So I want to find the square of 5i. Since I want to find the square, I'm just going to square 5i. That breaks down to 5 squared times I squared. 5 squared is 25. I squared, as I just said, is negative 1. So your answer is negative 25. Same thing here. If I have negative I times the square root of 2, I want to go ahead and rewrite that as negative I square root of 2 squared. And that is going to break down to negative square root of 2 squared times I squared. Notice that I put the negative sign with the square root of 2 because that's going to help us out here. Because that I squared equals something. So square root of 2 squared is just 2. So I'm technically going to have 2 times negative 1. And that's going to be times, or that's going to equal. So the square root of negative 2 squared is just 2. And then I squared is negative 1. So 2 times negative 1 is negative 2. Last but not least, when dealing with a quadratic, we want to find the imaginary solution if there's going to be one. So you can have a real solution or you can have an imaginary solution with quadratics. So we have x squared plus 12 equals 0. Again, solve the same way. I'm going to subtract 12 from both sides. I now have x squared equals negative 12, so I have x squared equaling a negative number. If there were no such thing as imaginary numbers, we would have a no solution. However, we can take the square root of that. We're going to have x equals plus or minus the square root of negative 12. Now this is where your imaginary number comes in to play. Technically, when you have the square root of negative 12, we're going to have plus or minus the square root of 12 times the square root of negative 1. The square root of negative 1 is I. And the square root of 12 we learned back at the beginning is technically 2 square roots of 3. So square root of 12 breaks down to the square root of 4 times the square root of 3. Square root of 4 is 2, 2 square roots of 3. So since imaginary numbers are written as b times I, this 2 has to come in front. So our answer is going to be plus or minus 2i square roots of 3. Same thing for part B. I'm going to subtract 11 from both sides. 4x squared is going to equal negative 5. I'm going to divide both sides by 4. X squared is going to equal negative 5/4. I'm going to take the square root. X is going to equal plus or minus the square root of negative 5/4. So again, since I have that negative under the square root, I'm just going to go ahead and pull out the I. X is going to equal plus or minus I square root of 5/4. And since 4 is a perfect square, that's going to come out. So this is technically the square root of 5 over the square root of 4, which is the square root of 5 over 2. So x is going to equal plus or minus the square root of 5 over 2 I. Real part before the imaginary part. And that is all for section 1. That was a longer section. We will practice on Tuesday after you guys do your homework. Homework is on the agenda.